standard form of an equation allows us to graph lines using 2 points, the x-intercept and the y-intercept. And standard form is ax plus by equals c, where a, b, and c are integers. So those are integers. I'm going to highlight that. A, B, and C are integers. And that's called standard form. AX plus BY equals C. We want to graph using X and Y intercepts. And this form allows us to do that very easily. So 2x plus 3y equals 12. When I want to find the x-intercept is the value of x when y is 0. So that's our x-intercept. I'm going to write that right there, x-intercept. The y-intercept is the value of y when x is 0. So when we're finding the y-intercept, we're going to put a 0 in for x and solve for y. Now let's look back at the original equation. And I'm going to, look at what I'm going to do. I am going to change my pen, and I'm going to make a big dark square. There we go. And now I'm going to just come back over here, and I'm going to use it to go like this. Hoo-hoo, hoo-hoo. Okay, awesome. I sound like an owl, don't I? Okay, coming back over here. 2x plus 3y equals 12. If I want to find the x-intercept, I'm going to put a 0 in for y. So that means it's going to 0 out my y term. So I have 2x equals 12. Well, 2x equals 12 means x equals 6. So 6, 0, 1, 2, 3, 4, 5, 6. 6, 0 is 1 point on the graph. And now we're going to, let's do this. There we go. Now we're going to find the y-intercept. It's the value of y when x is 0. So we kind of black out our x, and we get 3y equals 12, which means y equals 4. So 0, 4, 1, 2, 3, 4 right there. And then we grab our straight edge. We draw a line that goes through the 2 points. It's not nearly as beautiful as the slope-intercept form, but it works. And there's our line. Oops, there we go. Don't forget your arrows, and don't forget to enter and exit the grid. Okay, here's one for you to try. 5x plus 2y equals -10 using x and y intercepts. Okay, you go ahead and press pause, try it, and then I'll come back with an answer. Okay, I'm back, so if you don't want to reveal the answer, make sure you press pause. Our x-intercept is -2. Our y-intercept is -5. We draw a line that goes through those 2 points. Arrows at the end. We've entered and exited our grid, and there's our graph of 5x plus 2y equals -10. Okay, here's another example. We've got y equals -3. Y equals -3. Oh, there's no x. There's just a y, and it's -3. Well, that means that no matter what value we put in for x, y is always going to be -3. So if y is always -3, we're going to have a horizontal line we're going to have that horizontal line that goes through all ordered pairs where the y is a -3. Okay, you try the next one. It's x equals 2. X equals 2. What type of line do you think that is? Okay, if you are still listening, that means you've pressed pause, you've drawn your graph, and you're just checking your answer. X equals 2 is a vertical line. I put a point where x equals 2, and then I'm going to draw a straight line. I don't know what just happened to that point. X equals 2, and now I'm going to draw a straight line that goes through that point. Kind of messed that up a little bit. There we go. And I'm going to have arrows. Hot dog. There we go. Vertical line. So when you have y equals a constant, that's a horizontal line. Okay, going through that y value. And when you have x equals a constant, that is a vertical line. And we already know that our horizontal lines have a slope of 0, and our vertical lines have an undefined slope. So we're adding to our knowledge base. Okay, standard form. I already kind of gave that away earlier. AX plus BY equals C. A, B, and C are called parameters. A, B, and C are called parameters, and they are going to be integers. Now, in some books, some publishers go a step further and say that A has to be positive. So we'll practice with that. We'll practice making A positive. However, if you have a similar answer, I'll show you. Okay, here we want to write the equation in standard form using integers. So y equals 3/4 x plus 2. That's our equation. So that's our example right here that we're going to be working with. The first thing that we're going to do is clear fractions. So clear your fractions. So I'm going to multiply everything by 4. So every term gets multiplied by 4. That's why we spent so much time clearing fractions in that first unit, so that we knew how to do that for here. So we have 4y equals 3x plus 8. Now we're going to move x and y onto the same side of the equation. So we'll move the x and y terms to the same side and the constant on the opposite. And the constant on the opposite. So I'll subtract 3x from both sides. And now I have negative 3x plus 4y equals 8. For some publishers, this is okay. Okay, so for some publishers, this is okay because you've got ax plus by equals c. However, other publishers are going to say a step further, multiply by -1 to make a positive. So if we multiply each term by -1, we would get 3x minus 4y equals -8. Either one of these answers is going to work. Now, your homework answers may have the first equation. However, either one of those work. But if you change the sign of one term, you have to change the sign of all the terms. So if we want -3x to become positive 3x, then positive 4y becomes negative 4y, and positive 8 becomes -8. Okay, all of them change. So here's one for you to try. Y equals -2/5 x plus 1. Let's put that into standard form. Press pause and then come back and check your answer. Okay, if you're back, I'm just going to give you the answer. The answer is, drum roll, 2x plus 5y equals 5. Now this one, I would not say or negative 2x minus 5y equals negative 5 because that's too many negatives. That's just got too many negatives in it. I wouldn't even go there. 2x plus 5y equals 5 is a beautiful answer and the correct one. Okay, let's talk real world. Write an equation in standard form to find the minutes someone who weighs 150 pounds would need to bicycle and swim laps in order to burn 300 calories. Use the data below. So we're talking about bicycling and swimming laps. So how much would we need to bicycle? So here's bicycling right there. And how much would we need to swim laps? There's swimming laps right there to burn 300 calories. Well, bicycling, you burn 10 calories per minute. 10 calories per minute. Swimming, you burn 12 calories per minute. So 10 calories per minute. And we're going to take that and we're going to add, right? We're going to add to that 12 calories per minute. And that's going to equal a total of, what, 300 calories. Well, that's not going to work. Calories per minute plus calories per minute equals calories? No, the minutes have to go away. So I'm going to have to take 10 calories per minute and I'm going to have to multiply it by minutes. And then I'm going to have to do that here times the number of minutes. But are those going to be the same number of minutes? No, because I could spend more time bicycling than I do swimming, or I could spend more time swimming than I spend bicycling. So X is going to equal the number of minutes bicycling, and Y is going to equal the number of minutes swimming. So our equation is 10x plus 12y equals 300. And I like it when I box my answer and it's a perfect box. There we go. So there's our equation in standard form, 10x plus 12y equals 300. Okay, you try. We've got a fundraising problem. The sophomore class holds a car wash to raise money. A local merchant donates all of the supplies. A wash costs $5 per car, $6.50 per van or truck. Define a variable for the number of cars. Define a variable for the number of vans or trucks. And then write your equation in standard form to relate the number of cars and vans or trucks the students must wash to raise $800. $800. Okay, go ahead and press pause. And when you're ready to check your answer to both A and B, come on back. Okay, the answer to A, X equals the number of cars washed, not just the number of cars, but the number of cars washed. And Y equals the number of vans / trucks washed. And then B, for every car wash, that's $5 per car, so 5x. And then for every van or truck that's washed, that's $6.50. So that's $6.50 times Y is equal to $800. And there's our equation in standard form. So you can see how the entire world of math does not revolve around slope-intercept form. Standard form is so very, very, very helpful.